This is resist. Do you understand? So from resist, now you'll be able to what? Coin out what the word resistance actually means or meant. Now, looking at it very well, we realize that resistance is just the refuser. Do you understand? The refuser. This is your metallic wire. When this, if this wire refuses the movement of what? Electron to pass through it, it means that this wire, okay, let's paint a scenario here. This is a bar. Metallic bar. Are you getting it? Now, if you recall, metallic bar can be your conductor. This is another bar, but it's not metallic. Let me not call it bar. A log of wood. Let's put it as a log of wood. Now, this is a wood. Your wood is what? An insulator. Now, if you decide to incident a naked wire that has electron charges attached to it, you incidented both body with a naked wire. You realize that on this body there will be faster movement of electron. While on this body, electron will just stick here to not move. Why? Because this particular body is an insulator. Does not allow the what? Free movement of what? Electron. Why this particular body? There is no odor to just go straight up without any restriction. Meaning that if you have to analyze these two bodies in terms of what? Resistance, you will say would, let's say this is body B and this is body A. We will say body B has high or higher resistance. Has higher resistance than what? Body A. They ask, if you are being asked why, the simple reason is what? It's just the refuser of electron from one point to what? Another. But your body A has what? Allowed the movement of an electron. So meaning that your body B has higher resistance compared to your body A. So with these two analogy now, I think resistance, the meaning of resistance has actually been gotten. Now let's proceed to the grammatical representation of what? Resistance when it comes to your electrical circuit. Meaning that you can have one as resistance in series and what? And your resistance in parallel. What does that mean? We are looking at the circuit placement of what? The circuit placement method of your resistance, different resistances or different resistors. Let me put it that way. Resistance is what? An occurrence. While resistor is actually the body. Do you understand? Now, how do you now place your resistors on your what? Electrical circuit. We look at it in different ways. The first part in series. If this is to be your circuit, as I'm going to draw it, you will have something like this. Now, this is the circuit representation of resistance. This is your R1, this is your R2, and this is your R3. Now, mind you, when you have and this type of connection, let me put it this way. This type of connection is what we call series connection. This type of connection is what we call series connection, meaning that current is moving this way and it's going this way. Now, it passes through each resistance. This is V1, this is first voltage, this is V2, and this is your what? V3. Now, if you look at these three very well, you realize that same current passes through these three, as in forward movement of this current. The same current that move from point A, let me say this is point A, this is point B, this is point C, and this is point D. Current moving from A to B. Same current passes through these three resistors, R1, R2, R3. So, same EMF. They might now have different EMFs, but it is same current that passes through them. So, this particular arrangement of resistor on this particular circuit is what we call resistance in series. So, this is series, and our parallel is being drawn this way. You can have something like this way down, then you have it broken down this way, goes this way, Now from here, you realize that this is what? R1, R2, R3. Now, at this junction, it is not same current that passes through the three resistors. So it might be asked, you might be questioned that in a series connection or in your series circuit of what? In your series connection in an electrical circuit, are there same passage of current? You understand? In each resistance, the simple answer is yes. Why? Because considering this diagram now, the current is just moving, and same current, if 2 amps, 2A or 5 amps of current passes through, it's the same 5 amps that will pass through the 3. But at this junction, there is a breakdown. That is, you have I1, you have I2, and you have I3. Now, this is the general current that comes. It's actually coming from your cell here. So from here you have your normal general I, but when you get here, the what? The breakdown. So at this junction, you have breaking down of what? The what? Current. So it's no more same current that what passes through. That's just the difference between your resistance in series and resistance in what? Parallel. So this is what we call resistance in parallel. Resistance in parallel. So now the next thing that will come to mind is, we've now gotten the idea of current, we've gotten the idea of your voltage and your what? Resistance. Now, how do you now measure this resistance? How do you sum total them in order for you to actually what? Obtain your what? Your voltage, your value of your voltage. That's what we are looking at. So for your series connection now, the total resistance is just giving us for your series connection, we have, remember we said it is the same volts that passes through them. So you can have your normal V, which equals to your V1 plus V2 plus what? V3. So if you are to break this down, you're going to have your V. If you recall, your V is what? IR. So V1 will now represent IR1. Remember, we said it is the same current that is passing through. So this I will not change. So from there you have IR2. And this third one will have your what? IR3. So by the time you cancel them out, the whole I, you'll be able to obtain your what? Your total resistance as R1 plus R2 plus R3. That is the derivation of your what? Total resistance in series. But the one in parallel, how do you go about it? Mind you, it's not same current that is passing through. It's not same current that is passing through. So what do you do? What do you do? You have something like this. Or let me put it this way. In your series connection, this is what you have. We have to look at it in terms of voltage. So it is the voltage we actually use here. But for series, for parallel, what do you have? Is the current. You have your I equals your what? I1 plus I2 plus I3. What does that mean? It means that here I is equal. That is, I is constant. Why is the I constant? Because the same current passes through the three resistors. But here now, I is not constant. They are not of the same value. That's why. So if you are to break this down, recall your I is now your V over R1 equals V over R2 equals V over R3 plus what? Sorry, this is supposed to be RT, R1, R2, then R3. So if you are to cancel out your V, you are going to have what? 1 over R1 equals 1 over R2 plus what? Sorry, RT, R1, R2, R3. So this is the what? This is the total resistance in what? In circuit with what? Parallel resistance. For circuit with what? Series resistance. This is the total resistance. But for circuit in parallel, this is the total resistance. So from here now, we will be able to do some mathematical calculations for us to actually understand what is meant by resistance in series and parallel. But before we go into that, let's look into the electrical circuit properly. Electrical circuit. So Looking at this now, we've now gotten the proper understanding of what you meant by. Remember, we said we want to talk about potential difference, resistance, and your electrical current. So at this junction, we've spoken about resistance, spoken about electrical current. Now we are left with potential difference. Now let's start with what? Electrical circuit. Electrical circuit. Sorry about the writing. Electrical circuit. Now this region, what's an electrical circuit? What is actually meant by what? An electrical circuit. Electric current will flow only if there is a complete circuit of conductors by which current can leave from one terminal of the cell to another. What do we mean? There is a complete circuit of conductors, meaning that your wire must be conducted as, must be used for the connection in your what? Electrical circuit. You must now have a lamp. This one actually, this is the diagram of a lamp. Do you understand? So we have your lamp here. You must also have a battery. Your battery is now situated here. This is your plus minus. Now that's a battery. Now you must now what we call your switch. So this is a complete circuit of electricity. You have the battery, you have the conductor, you have the lamp, and we have the switch. There must be a switch. This switch, you can switch it off. You can switch it on when you connect this switch to this one. And you can actually what? Switch it off when you what? Detach them. So with that,